Hi, today we're going to make a simulation from scratch in the MTS simulation software. I'm going to be using the Haas VF2 machine, and we're going to be using SolidWorks and CamWorks to post our program to be able to put it into the simulation software. So we're going to start off with this simple part. We've got a part here. He's going to be 4 inches by 4 inches by 1 inch thick. Make it nice and easy to set up in our simulator, and we're going to mill this upside down T-shaped pocket, and we're going to spot drill and tap these 5/16 18 holes. Now we're going to be using, as I said, SolidWorks is the CAD tool that we use to create our model, and then we use CamWorks, which is a plug-in into SolidWorks, in order to generate the tool paths. We created a pocket, and then we did a rough and a finishing from that pocket, and then we created a whole group in order to program our holes. In the operations, we used a 1/2 inch flat end mill, did a zigzag pattern to clear the material, and then we just did a profile. Cut the finish, we used a 1/2 inch countersink to spot the holes to pre-drill, 257 drill, and then a 5/16 18 tap. So we need to set up our simulation environment so we're ready to simulate this. So I'm going to go to my simulation software, my MTS software. We're posting this in with a Haas post processor. So I'm going to use my Haas VF2SS, and we're going to use the Haas controller on the Haas VF2SS machine. I'm going to leave this on my NC Programs folder so I can start a blank simulation and go right into the simulator. From here it comes right into our home screen or our start screen, and I'm going to say create a new program, and we're going to call it Plate 5. Now we've got a couple of options for setup. We can do a setup from a template if I already had a magazine of tools. We're just going to do a default setup. I could do an empty program if it was a sub program and I didn't want any tools. I wanted to call it from a main program. But we're just going to do a default setup. And OK. So here we fill in our preparatory information. We'll call it milling department. Project will be Plate 5. Accept that. Let's go ahead and attach a drawing. Our drawing of identification. I've already created a PDF. So we're going to look into the in CAD folder. And we're going to find our Plate 5 PDF and attach that. Now we have that attached to our simulation, so we can always refer back to our drawing if we need dimensions or any information. Program number is going to be 1, and we'll leave the program file name empty. From here we're going to work across. Workpiece and clamping devices. First thing we do is define our workpiece. If you remember, our workpiece was 4 inch by 4 inch by 1 inch thick, 4 inch wide, 4 inch tall, 1 inch thick. So X is going to be 4, Y is going to be 4, and Z is going to be 1 inch thick. If your installation should happen to be showing in the metric mode, so you have millimeters here, simply go to options and make sure you have checked unit of length inch. We've defaulted to bronze material. If we would like, we can switch that material. We click the open and we have all the ISO indicators of material. So we're going to use a non-ferrous material and choose an aluminum. Now you see our material has changed color to an aluminum color. Next thing we're going to do is look at our clamping. We're okay with this clamping. If we chose to make a change with the vise, we could select a jaw chuck, a 3-jaw, 2-jaw, 4-jaw chuck. We could use the modular clamping system and use top fix in order to use clamps or bring in our own unique work holding. But we're going to leave it to a vise. If we wanted to change our vise to a different size vise, we would simply click the file open and select one of the many different vices that we have available to us in our library of vices. But we're good with the vise that we have. We can edit the depth. The chucking depth defaults to a number. If we wanted to hold it by more, let's say we want to hold it by a 1/2 inch, we change that to a 1/2 inch, and our material is a 1/2 inch deep in our vise. You see we have parallels. If we did not want parallels, we could just uncheck the parallels and they're gone. I think it makes sense to use parallels on this job. And maybe our parallels are 3/16. So we can edit the thickness of our parallels. So we have our work holding, we have our raw material. We have to set our origin. The origin defaults to the top left side of the workpiece. Let's look and see. Mill part setup 1, it appears as though the programmer chose the far back right side top for our origin. So we need to edit our origin location in our simulation. So we have a drop down box. We've got a lot of options here. We're going to say top side right back corner. And we make sure our offset values are zeroed. If I wanted to offset, for instance, if I had oversized material in the thickness and I wanted to face 20 thousandths, I could say Z minus 0.02. That would lower my work offset by 20 thousandths from the top, giving me material that I could face if I needed to. But we don't need that. I'm going to zero those values, and that sets my work offset. Next, we're going to check our tools, and we're going to edit our magazine so that we have the proper tools. I'm going to start with a fresh magazine, so I'm going to right click on each of my tools, and I'm going to say remove. Right click and remove. Now we started out with a 1/2 inch end mill, so we're going to right click in station number 1. We're going to say exchange, or you can use Control E, and that brings up our library of tools for this machine. Now if you don't see the inch tools and you want to work with inch tools, each of these that start with inch are our inch tools. Those that don't contain metric tools. View, show types with inch tools needs to be checked in order to see the inch tools. So we need an inch flat end mill, and we need a 1/2 inch flat end mill. Now what I want to do is I want to order these by the diameter. I can order these via any of these columns that I want to, largest to smallest or smallest to largest. I want to order them by the diameter. I'm going to click the D, and that's going to order them smallest to largest. I can scroll down and I can find my 1/2 inch end mills. I have several 1/2 inch end mills here to choose from. I would prefer a 3 flute end mill. I don't find one, so I'm just going to use a 4 flute end mill, and then we're going to edit it. So I accept that tool. I don't want to see this tool cut with a red color, so I'm going to right click and I'm going to say Workpiece Color Selection, and let's make him green. Also, we don't need the gauge length to be 2 3/4, and we needed to make a 3 flute end mill. So I'm going to right click. I'm going to say Modification All. I'm going to scroll down to my end mill. Teeth number is set to 4. I'm going to change that to a 3. When I do that, you see I've changed to a 3 flute end mill. My LA number, my stick out is 2 3/4, so I'm going to look at the LA and I'm going to change him to 1.5. Maybe 1.75. We don't want to bury it into those flutes. Now I'm happy with this tool. Green check accepts it. Now I have my tool. We needed a 1/2 inch by 90-degree spot drill, so exchange, right click and exchange. Spotting drill, double click. We're going to order these by diameter. I do not have a 1/2 inch, so I'm going to use the 90-degree by 0.472, and we're going to edit him. So we're going to accept that. Right click, modification, length and diameter only. I'm going to change my diameter to 0.5. Tab to accept that and OK. Now I have a 1/2 inch spotting drill. Tool number 3 was a 257 drill. So I'm going to right click, exchange. I'm going to go to my inch twist drills, inch twist drills. I'm going to order these guys by size. Click once, I've got largest to smallest. Click again, smallest to largest. We need to find a 257. I've got a couple options for 257. I'm going to go with the shorter of the two options and accept him. And then finally I need my 5/16 18 tap, so station number 4, we're going to exchange him. Inch tap, ordered by diameter. We're looking for a 3/12/5 or a 5/16 tap. The pitch is of an 18 tap is 0.0556, so we're going to get a 0.0556 tap. Be careful, make sure you get an M3 or a right-handed tap. M4s are left-handed taps. This tap is a little longer than I'd like, so we're going to edit him. Right click, modification all. LS is 2.5. We're going to scroll down till we have our tap. We're going to edit our LS. Make him 1 inch. Our LA, 3 7/90. Let's make him about 1.750 as well. That looks a little more reasonable. This is a 4 flute tap. Let's call him a 3 flute tap. We're happy with him. We'll accept him. Right click and let's change our color to a blue. Check to accept our magazine, and now we have a good magazine, we have a good setup. We accept that and we're ready to go. I'm going to go to my editor. We have no program, so we're going to go back to our CAM system, our CamWorks. Pardon me. And we notice we have tool 1, 1/2 inch end mill. Tool 12, 90 by 1/2 inch countersink. We use tool 2. Tool 3 is our 257 drill, and tool 4 is our 5/16 tap. We've got a couple of options. I can right click on the machine and say Reorder Tools, and I can order them 1 through 4, or I can right click on this one on my countersink, edit definition, and in my tool tab in station we'll call him tool number 2. Okay, and now we have our tools in the correct order. We're going to post process. We We have our program. Control A to select it all. And we're going to copy that program. And we're going to paste it into our simulation. Control S to save it, and we're ready to check it out. Now we're going to have an error. Let's look and see. Automatic. Let's remove some of our detail. Let's lock this to our machine and our workpiece. Reset, and we're going to cycle start. Take it out of single block mode. Coordinate system looks correct. Feeding our tool in, our zigzag roughing. Let's go to 2D mode. Our finishing looks correct. Change to our 1/2 inch spot drill. Spotting looks good. Our 257 drilling. We've got a peck. Looks good. And the 4th hole. If I wanted to turn the clock up to go along a little faster, I could, but we're going to go slower for our tapping. 5/16 18 tapping is done, and it looks like we're good. Notice I had no collision detect on, so let's turn collision detect on, reset, and let's run that through one more time and make sure we don't have any collisions. Always a good idea to leave collision detect turned on. That's the value of the simulator, is knowing whether you're going to have a collision before you find out on the machine, right? We turn our clock up a little bit to get through this quicker, and no collisions. Looks like it's a success, and it looks like we didn't have errors. It's going to be a good day. So let's look at our drawing. It appears as though it looks like the drawing, but we need to verify, don't we? We need to verify. So we're going to go to measure. Looks like I can see all of my part. I don't really need to move my section anywhere. I could if I needed to, but my section right in the middle looks pretty good. I need to put some measurement points in the centers of my holes. I need to see my drawing here. Let's resize him, so there we go. We'll move him over. We'll put our drawing right next to it. There we go, and let's see. We need to know our locations of our 4 holes. So we're going to say from the origin, this is 750 and a 1/2 inch, so we're supposed to be on this guy 750. We're supposed to be a 1/2 inch. We're good there. 3 and 250, we're looking for 3 and 250, so we're good. 3.5 inches, 4 inches minus a 1/2, or we can measure from this edge if we want to do that. From the bottom edge to this hole is 0.5, so we're good. Looks like we're in pretty good shape. And we can double check the size of our pocket. We're supposed to be 1 and 375. We're 1 and 375. We're supposed to be 2 and 625. We're 2 and 625. Very good. And then the height's 3 inch. Looks like we're 3 inches here. And 1 inch. Looks like we're 1 inch here. So it looks like initially we've got a success. So there you go. It's as simple as that to create your own unique simulation. We edited some tools. We changed our colors of our tools so we could see what each tool was doing. Post-processed a program, pasted it in. and we have a successful simulation. I hope you're as successful in your first simulation. Good luck, and we'll see you in the next video.